Hello everyone, welcome back to my channel Explain Maths. In this video, I am going to solve assertion, reason and case study questions of the chapter Real Numbers. And I am going to explain in detail, step by step, that how to answer the assertion, reason and the case study questions. So let's begin the class. So this is the first question, which is assertion, reason type. Assertion says that the number 5 to the power n cannot end with the digit 0, where n is a natural number. And the reason is given as prime factorization of 5 has only two factors, 1 and 5. So let's first see the assertion. It says that 5 to the power n cannot end with the digit 0. So let's see whether this statement is true or not. So if I take few examples, like the number which ends with 0. Okay, so I am taking few examples, like if you take number 10. And if you do the prime factorization of 10, you are going to get 2 into 5, right? Then next number I am taking as 20. Both the numbers, if you see, there is 0 in the unit place. Now 20 is 4 times 5. 4 I can write as 2 into 2 into 5. Next, if I am taking 30, so 30 will be 2 into 3 into 5, and 40 will be 2 into 2 into 2 into 5. Now, if you notice here, in all the numbers, all the four numbers having 0 in the unit place, if you see their prime factorization, the factors which is common in all is 2 into 5, isn't it? If you see here, here also you see 2 into 5, and here also it is 2 into 5. It means if a number has to end with 0, it should have 2 and 5 as their factor. And 5 to the power n, 5 itself is a prime number, isn't it? I can write only as 1 into 5 to the power n, which can be further written as 1 to the power n into 5 to the power n. Yes? So here you can see 2 is not the factor of it. So we can say that 5 to the power n will never end with 0. So from here I can conclude this assertion is true. Okay. Now if assertion is true, then your D option you have to eliminate, because here it is given assertion is false. Next, it is given, if you see the reason, it is given as prime factorization of 5 has only two factors, 1 and 5. So here you see it is given prime factorization. If it is not prime factorization, it is just given factors of 5, then I can say it is 1 and 5. It is true. But it is given prime factorization. So prime factorization, if it is given, then 1 is not a prime number, isn't it? So this reason is, this statement itself is false. So from here we can see C is the correct option. Assertion is true and reason is false. So whenever you have to solve assertion reason type of question, first you check whether the statement given for both that is true or not. Okay. And then you have to look for the options. If both you can see assertion and reason are true, then C and D option you have to eliminate. Then your correct option will be either from A or from B. Correct? So like that you have to first analyze whether the statements given for assertion and reason that is true or not. So hope it is clear to everyone now how to solve the assertion reason questions. And these questions I am explaining because your board exam is going to start soon, and it will be really helpful for you to solve the assertion reason type of questions. Now I'm moving to next question. Question number 2. Now this is a case study question. Teaching mathematics through activities is a powerful approach that enhances students' understanding and engagement. Keeping this in mind, Miss Mukta planned a prime number game for class 5 students. She announces the number 2 in her class and asks the first student to multiply it by a prime number and then pass it to the second student. Second student also multiplied it by a prime number and passed it to the third student. In this way, by multiplying to a prime number, the last student got 173250 as the number. Now the question is, Mukta asked some questions based on that, and the question is, what is the least prime number used by the students? Now to solve this, first we have to do the prime factorization of 173250. Okay, so let's do it. So 173250. First number was given by the teacher and the number was 2. So we will start the factorization with 2. So 2 table, it will come 86,625. Now the second now this 2 number teacher has given to the first student. Now first student multiply now some other prime number. So if you see here, this number is divisible by 3. So I will use here now 3. So it will be 28875. Now next will be again 3 table it will go. So it is 9625. Now it will go in 5 table. So 1925. Next again 5 table 385. Again 5 table 77. Then 7 table 11. 11 times 1. So now this is the prime factorization. So let me write here, it is 2 into 3 into 3 into 5 into 5 into 5 into 7 into 11. Now this first number is given by the teacher to the first student, isn't it? Now first student multiplied 3 and then he passed to the second student. Again second student multiplied 3 and pass it to the third student. Third student multiply 5, pass it to the fourth student. Fourth student multiply 5, again pass it to the fifth student. Fifth student multiply 5 and pass it to the next sixth student, and then sixth student multiply 7 and pass it to the next student 7. And then it became the number 173250. Now the question number 1 is, what is the least prime number used by the students? So the least prime number used by the students. 2, the prime number 2 is given by the teacher. So you should not write 2 here. The number which is used by the student. So the least prime number is 3. So the answer for the first one is 3. And how many students are there in the class? From here you can clearly see there are 7 students in the class. And what is the highest prime number used by the student? The highest prime number used is 11. You can see here at the last in the prime factorization we have 11. And which prime number has been used maximum times? So you can see 5 is used here 3 times. So it is 5. So this is the question number. This is the first case study question, and this question was really very easy. Now moving to next case study question. So here it is given that February 14 is celebrated as International Book Giving Day, and many countries in the world celebrate this day. Some people in India also started celebrating this day and donated the following number of books of various subjects to a public library. And they have donated history, book of history 96, science 240, and mathematics 336. These books have to be arranged in minimum number of stacks such that each stack contains books of only one subject and the number of books on each stack is the same. Based on the above information, answer the following question. How many books are arranged in each stack? Now see, you have to read this part very clearly. It is given these books have to be arranged in minimum number of stacks. It means the number of stacks which you have to use, that will be minimum. Now let's see what is a stack. Stack is something like this where you keep the book one above the other. So you have to make a stack, and what is the condition given? Each stack will have same number of books and same subject book. So if first stack is history, maybe second stack is also history. Then third is science, fourth is science, and so on. It is like that. All the each stack should have the same subject as well as same number in each stack. Number will be same in each stack, but each stack will have the same subject book. It should not be like it is a mixed match of math, science, history all together. No. Each stack should have the same subject book. And it is given stack should be minimum. Now you only think when the stack will be minimum. This stack, the number of stacks, okay, the number of stacks will become minimum if the number of books in each stack is maximum, isn't it? Suppose you have 40 books, okay, if you have 40 books, if in each stack if you are keeping 4 books, so you need 10 stacks to keep all the 40 books, isn't it? But if you keep in each stack, if you keep 10 books, then what happens? You need only 4 stack. And when the stack is becoming minimum, when the number of books in each stack is maximum, isn't it? Moreover, if you see, the number of books are nothing but the highest factor of the total books, isn't it? So what I mean to say, to get the minimum number of stack, first thing, the number of books in each stack should be maximum. And the number of books are same in all the stacks, it means they are the common factor. So it means now it is very important to understand whether you have to find HCF or LCM. So from here, clearly it is, you can recall that you have to find here HCF, because the number of books which you keep in each stack will be maximum, as well as that will be the common factor of these books, these number of books. So what you have to find? You have to find the HCF of 96, 240 and 336, and that will give how many books are to be kept in each stack. Okay, so let's solve the first question now. So now it is clear, I think, that you have to find HCF over here. Okay, don't see that. Many times I've seen that children will see, oh, minimum. So you have to find LCM. It is not like that. You have to interpret the question properly. Now moving to the first question. How many books are arranged in each stack? So I have told that you have to find the HCF of 96, 240 and 336. So let's find the HCF of 96. So 96 is an even number, so clearly it will go in 2 table. So 2 times 48, then 2 times 24, 2 times 12, 2 times 6, 2 times 3, and then 3 times 1. So this is the factorization of 96. Next we have to do the factorization of 240 also. So again 240 is an even number, so I will start with 2. So 2 times 120, 2 times 60, 2 times 30, 2 times 15, times 5, and 5 times 1. Now next is 336. So again we have to start with 2 table. So 2 times 168, then 2 times 84, 2 times 42, 2 times 21, 3 times 7, and 7 times 1. So the factorization is done now. So 96 I can write as 2 to the power 5 into 3, isn't it? Here you can see 2 is multiplied by itself 5 times. Then 240 you can write as 2 to the power 4 into 3 into 5. And 336 is 2 to the power 4 into 3 into 7. Now you have to find HCF. So first of all, you have to see what is the common factor. So common prime numbers I can see 2 and 3. And what is the lowest power of 2? That is 4, and lowest power of 3 is 1. So from here 2 to the power 4 is 16. 16 into 3 is 48. Okay, so it means in each stack you will have 48 books. Okay, 48 books are arranged in each stack. So this is the answer for the first one. Okay, now moving to the second part of it. How many stacks are used to arrange all the mathematics book? Only mathematics book if you have to arrange, how many stacks you need? Now we know that in each stack we will have 48 books, right? So now this 336 books you have to divide equally, 48, 48, 48, isn't it? It means to get the number of stacks you have to divide 336 by 48. And if you divide it, you are going to get it as 7. 48 times 7 is 336. Now the next question is, determine the total number of stacks that will be used for arranging all the books. For all the books total, how many stacks is needed? So you see, for history, 96 books, and we know that in each stack you will have 48 books only. So now divide it, 96 by 48 plus 240 by 48 plus 336 by 48. Why I am dividing? Because the question says that in each stack you will have equal number of books. So to keep 96 books, each stack will have 48. So 48, 48, 48 like that. It means you have to distribute equally in 48, 48 of all these books. So I'm dividing it. Whenever you have to do equal distribution, you have to divide, right? So 96 divided by 48 will give you 2. 240 divided by 48 is 5 and this is 7. So you will get 14 stacks are needed to keep all the books. Clear? So this is the case study question. So I hope it is clear to everyone. And these case study questions, if you see that for real number, you'll find it very less case study questions. Okay. These questions I have taken from your previous board paper only, and please prepare well for your exam. So that's all for today's class. Bye.